Solving a triangle means to find all the angles and all the sides. Now, the problem with this instruction is it should be very simple, yes? Right? Find all the sides, all the angles. There, no problem. There you go. What happens every year I teach this class, every time, is I do this question. And all of you copy down what I do and then assume that that is the order you must do this in. Because you wrote it down, Mr. Myers. That is not the case. Your goal is to find all the sides and all the angles. At your disposal, you have 4 pieces of mathematical knowledge. One is Pythagoras, right? One is SOHCAHTOA, trig. A third one is all angles add up to 180. And the fourth one is you know how to do math. You know how to do it. It is your question. And I've said this before and I will say it again. Learn the math, not the method. So when I solve this triangle, I may not do what you would do with this question. I may spend 3 minutes doing this question before I get to something you would start with. And every year I get kids asking me, Mr. Meyer, why are you teaching it that way? I don't get it. Say, just wait till we get to the end, student. And at the end of it, I tell them the 3 sides and 3 angles. Say, oh, that's what I got. Understand? There is no right order to do this. There is no right or wrong method to choose. Okay? Because in the end, you're going to know if you've done it right, regardless of whether or not you used Pythagoras or all 3 sides adding or all 3 angles adding up to 180 or whatever method you did. Understand? But some of it is the same. For example, the only thing I have in this triangle is a theta of what? 65. Now, as soon as I know that theta of 65, do I not know the third angle automatically? Of course I do. Why? 65 plus 90 is 155. 180 minus 155 is 25. So this angle right here has to be 90 minus theta, doesn't it? Because this 90 is covering 90 of my 180. So right away I know this angle is 90 minus theta, which is 90 minus 65, because I just said theta over here. So I know that's 25 degrees. Now if I do that first, that opens up using SOHCAHTOA on wherever I want, yes? I could do SOHCAHTOA with 25, couldn't I? Some of you will want to do that. Is that okay? Of course it is. I am not going to do that. The way I like to do these, and I stress that verb, like to do these, is I like to stick with the theta that I have. And I do all my work based on the theta that I have. Again, that's the way I like to do this. The verb was not, this is the way I always do this. So, if I'm going to make that theta, that makes that 41 what? Opposite. So I have an opposite of 41, right? Once I have an opposite, that means I can do 2 kinds of trig. What 2 kinds of trig can I do? What uses opposite? Sine and tan. So I can do sine of 65 equals opposite 41 over h. And I can do tan of 65, which will get me opposite 41 over adjacent. Now, I have the third angle. I have my A and my H. Do I have everything I need? Yes. Now, some of you will say, Mr. Myers, I don't like having the unknown on the bottom. I screw up doing that division with my calculator. I mess it up every time. That's okay, student, because you also know this side is 25, right? So you could do some work with the 25. But you're still going to end up, that's only going to help you with the tan side, isn't it? Everybody with me? So what am I going to need to do in green? What do I need to do there? What is H going to equal? 41 over sine 65. And what is A going to equal? Over tan 65. And I already know the third angle. Now, where can I split this off? Right here, once I know hypotenuse, could I go ahead and do Pythagoras? Could I? Sure. Once I know adjacent, could I go ahead and do Pythagoras? Yes. Is it right or wrong? Or neither? It's something I can do. Is it something I have to do? Is it wrong to use Pythagoras? No. Is it right to use Pythagoras? It can be, because you can also find them using trig. So it is neither right nor wrong. It is just what you like to do. Okay? Now, this is a unit on trig, so I choose to do as much trig as possible to practice my trig. Understand? I don't like to use Pythagoras in this unit at all if I can avoid it, because I learned Pythagoras in grade 7. Everybody got it? All right, but that being said, can you use Pythagoras? Please do whenever you want. Everybody with me? Great. Do this page in class right now. Go. Would somebody like to offer their answers to number 1? Because it's not that tough. What is the missing side? 4. Excellent. What are the two angles? 53 and 37. Nice work. Good job. Here are all the answers. Make sure you have those answers. If you don't, ask. If you don't ask, how on earth can I help you? It would require me to be a telepath, which, as you all know, is the worst superpower. Because then I would know what was going on in all of your heads. You think it is loud in this room when you guys are just talking? Imagine if I could hear everything going on in your heads right now. Secondly, why would you ever want to know that? People are, what did we start this class learning? Stupid. Why would I want to more proof of that? I already know. Just go to an airport or a train station.
Or a teacher conference.
Yes.
I flew alone when I was 12. It's not that hard.
My first flight alone was like 7.
12.2, 50, 14.6. 19.5, 36, 54. 16, 74, 24. 45, 5, 7.1. That's the triangle you needed to draw. That's the triangle you needed to draw. Yes, Ria. Of course. Ms. Gut.
Do you want we just a triangle? Or can we just put it in like?
If you do not feel you need to draw the triangle, then you do not need to draw the triangle. I have done enough trig that I very rarely need to draw a triangle for any trig question. But I've done a lot of trig. I recommend drawing a triangle always.
No, I'm just wondering if like if you take off points.
Nope. If you can do trig without the triangle, you do trig without the triangle, sister.
Except I can't.
Well, then you should draw the triangle.
I did.
Then you're going to do fine. If you draw the triangle, it's almost impossible to do trig wrong.
Oh. You bet I can find a way.
It's not complicated like finding out where the keynote speaker is.
True.
I
It's like it was on the bright yellow.
I know, I was here.
Where were you? Like, I did not see it at all.
Because I'm like a ninja. When you turn the page over to page 63, you can ignore the first little bit of it. But let's go to page number 9. Okay. From now on, all of your trig is word problems. What is the only thing in common between every trig question? They all have a triangle. At your people's level right now, all of those triangles are what kind of triangles, Luke?
Right triangle.
Right triangles. So you always are going to need a right triangle. So you can almost always draw one. Does it have to be to scale? No, it just has to be a triangle. It doesn't even matter. Do you need to get out your ruler and your protractor and make sure that it is exactly 90 degrees? No. You know that that's the 90 degrees. Then what do? You apply the question to the triangle. Ike standing on a soccer field and looks at the roof of the school. Where must Ike be? On the left or on the right, as I have drawn my triangle? On the left, because he's on the ground and he is away from the school. Where is the school? Well, that's the wall. Ike looks up to the roof of the school with an angle of elevation of 30. Where is the only angle of elevation in that triangle? Is it A or B? A. So this is your theta. And what is it? 30. What else do we know? Ike is 42 meters away from the base of the school. Where is the base of the school? Bottom right. Ike is 42 meters away from it, so that must be that side. And that is all you do with every trig question with which you will ever be faced. Draw the triangle. Figure it out. What do you have? Theta of 30. Adjacent of 42. You want to know the height of the school. That would be over here. X, which is opposite. What uses A and O? Tan. Tan 30 equals O. X over A, 42. 42 tan 30. Now, what if you were going further with this question? What if you were going to use this measurement again? Should you leave it? Or should you keep the operation for further use? Which is more important? The operation. Because if we're going to use that measurement later, we want it to be as exact as possible. And if you round here, in this case, go ahead and round. But if you're going to go further, you'll probably want to leave it as 42 tan 30. Does everybody understand what I mean? All right. Let's look at the next question. Abby is flying in an airplane at 2,500 feet. Okay? Where would you draw the beginning of this triangle? Up in the air, near the top. So here is our good friend Abby. She's flying Air Myers. The gate was A35. She had to ask people where to find it. Her seat was 19F. She couldn't find it. She brought in stuff that was too big to go into the overhead bin because she couldn't read and understand that you have to measure your items. She was a giant pain in the rear. Everybody with me? All right. Abby looks down and sees the town of Mission. Where is the town? On the ground. Mission. Do we have a triangle? Yes, because Abby is up in the air. She sees Mission. Now make the triangle. Well, how will we draw this triangle? The question says we need an angle of depression of 15. Is the question in charge, or am I in charge? I'm in charge. If she sees with an angle of depression, then what would me on the ground see with? An angle of inclination. So if her angle of depression is 15, what is my angle of inclination? 15. So I could have 15 with me looking out and up to her. And how far is she in the air? 2,500 feet. Or Abby, who would look out the window first to establish the baseline, and then down to the town of Mission with a 15 there. And that would be 2,500. Does it matter how you draw it? No. The mistake that you are all going to make when you do this test for me is you're going to draw the red triangle and you're going to say that this is the 15. You are. Maybe not you. But some of you are going to do that because you are going to tell me that that is an angle of depression. Even though we did this whole page with angles of depression and inclination, which I must have deleted because I ran out of room. So don't do that. So you either have to do this or the red one. Does it matter? No, because you are still using opposite for the vertical and adjacent for the horizontal. In red, opposite, adjacent. You're still going to use tan no matter what. Correct? Theta equals 15. Opposite equals 2,500. Adjacent equals, I'm going to use the letter Y. Why? Because I can. What uses O and A? Tan 15 equals O, 2,500, over Y. The unknown is in the denominator, so what math do we do?
Division.
2,500 divided by tan 15. Hard to do on your calculator, especially if you have a backwards one, so please be careful. When you get an answer, make sure that it makes sense. And what do we have for an answer? $9,330.1. 0.13 if we were going to go to 2 decimal places. Does that make sense? Yes. Okay. Oh, number 11 makes me cry. See if you can figure it out. Just try to draw the triangle. Talk to your neighbor if you need to. Read the question carefully. And let me tell you this. There's two ways to solve this problem. Will I care which one you use? Daniel, do I care? No. If I start solving this problem in the method you didn't use, will you put your hand up and say, whoa, Mr. Myers? Or will you wait till we get to the answer? You will, of course, wait till we get to the answer. I need to draw a triangle, right?
No.
You don't need to, but most people will. What will a triangle look like? Well, if the road was a flat road, it would look like that, wouldn't it? Except it would be a straight line, yes? But the road is not a flat road, is it? The road rises. So the road goes up 1 meter. I'm going to use black to draw the road. Wait a minute. Let's have some fun with this. Because that's what I do. I make math fun.
Really?
There's the road. Wait.
What is that? Oh.
I thought it was like an amoeba for a second.
Ah! Big tires.
You gotta adjust up there.
Where does the 19 go?
Nowhere. I mean, it's
On the hypotenuse. Because you are measuring along the road.
actually, you're right.
You are not drilling through the hill and then putting in an elevator to go up.
Hold on. It says 1 meter for every 19.
Meters measured along the road.
There we go.
So that is the triangle you have, yes? I want to know how far I will travel horizontally if I travel 300 meters on the road. So the triangle that I need has 300 meters of road, 300, and I need to know this number. Can I find that out using trigonometry? I can. Can I find it using similar triangles? I can. Because these are the same road, yes? So this angle right here, theta, is the same in both, isn't it? So if I compare 19 to 300, right? Then I would compare 1 to this side, and I would compare that to that side. So if I use Pythagoras to find this side, I can do the fraction thing, because this is, of course, the square root of 19 squared minus 1, right? Right? Which is 361 minus 1 square root of 360, 18.9.
It would be 19 because it'd be 18.97.
Yeah, but it can't be 19 because 19 is the road. You have to,
So you would do 18 18.9.
This is no, because it's 18.97. So how do you do it? When you do this math, your calculator gives you a huge number, yes? It's on your calculator, right? We're going to need it again. So we leave it there. If you're going to do this method, 19 compares to 300, and the square root of 360 compares to what here? B. And then you do the math. If you're going to use similar triangles. What's the other method? You can find what theta is. Theta equals shift tan, not shift tan, you idiot, shift sine of 1 over 19, correct? Then that will go right in there. And now I have that angle, hypotenuse, and I need the cos there, don't I? So I could also say cos of theta equals b over 300. So 300 cos theta will also give me the right answer. What is it?
Still got the same. 301.5.
How can that be 301 if the hypotenuse is 300? What's the answer? 299.6. If you did it this way, you multiply the pair and divide the spare. So you did 300 times the square root of 360 divided by 19. And you get 299.5 or 0.6. Do I care which method you use? Does everybody understand both methods? Because sometimes you're going to want to use similar triangles and sometimes you're going to want to use trig. Knowing both means both of them are in your mathematical arsenal. And you should have a good mathematical arsenal. So you can do the right thing at the right time, even though there's more than one way to do most questions. Everybody cool? Those questions are hard, not because the math is difficult, but because you guys tend to not read the questions carefully in your desire to get your work done. For example, my good friend Luke, who is an A student, drew his first triangle wrong, didn't he? He put the 19 down here. Everybody with me? I've said it before, I will say it again, I will go to my grave saying it. There is no prize for doing work quickly. There is a prize for doing work correctly. Please understand the difference. Next question is an easy one because I give you the triangles, yeah? If I'm going to do number 12, to find the area, I need a length and a width, yes? Now, I want you guys to do your best to give me the best answer you can for this question. Now, I've not told you what that entails, so show some work. Tell me what you did. Somebody talk to me. What'd you do to get me the most exactest answer you could? How did you start?
I started by finding the other angle. Actually, that doesn't matter. I don't know why I found that.
Did you start by doing some trig?
Yeah.
What trig did you start with? Did you have a theta?
Yeah, which is 21.
21. What else did you have?
I had the hypotenuse.
You had an hypotenuse, which was 12.7. And what did you need?
I needed the opposite side.
You needed the opposite, which was W, and the adjacent, which was L. How did you find W? What used O and H?
I said sine 21 equals O over 12.7.
Equals O over 12.7. So what does O equal?
12.7 times sine 21.
Sine 21. Now, since I want the most exact answer possible, should you have gone to your calculator yet? No, why not? Because then you guys will automatically round that decimal. Automatically. Does that give me the most exact answer? No. So you're going to stop there. Then what did you do? Cos of 21 equaled A over 12.7, and A equaled 12.7 cos 21. What did I know about area? It's length times width, which was O times A, wasn't it? And O times A is 12.7 sine 21 times 12.7 cos 21. Now I go to my calculator. What do I have to remember when I am punching this schmozzle in? Brackets.
It looks like a triangle I am supplied.
How do I punch it in? Bracket. 12.7 times sine 21, close brackets, times bracket, 12.7 cos 21, close brackets, equals. And then, and only then, do you round. Does everybody understand? I know it seems picky and persnickety, and Mr. Myers, that's not the way I like to do my work. That's fine, but be aware that trig, the operations of trig, don't get any more difficult. The level of work involved gets more and more difficult. What I mean by that is you may need to go further and further down the trig rabbit hole, and you want the best answer. Every time you round, you lose exactitude. Do you understand me? A shorter word for that is you will lose accuracy every time you round. So round as little as possible, which is why we do it this way. Do you have to? No. If you round it out up here, you're going to get an answer very close to this, right? Right now, in today's marking scheme, everybody would get the same marks. If the marking scheme has changed and you show me you can do this, that's the 4. Rounding up here is the 3. Do you understand me? Everybody understand? This shows a higher degree of competency with mathematics. And that is our goal. Yeah? Yeah. Uh-oh. Another double triangle question. Which means what? Show work and round when? At the end. Should I pick up my calculator and go right now? No, because you don't even know what you're looking for. What am I looking for?
The length of MN.
MN.
Which is the opposite.
To do MN, I must be dealing with this triangle, yes? Which means I need 2 pieces of information. Do I have it? What are the 2 pieces I need to solve a triangle?
2 sides.
I need either 2 sides or
1 side and an angle.
1 side and an angle. Do I have either of them for Greenie here?
No.
No, so I better use blue guy. Do I have that knowledge for blue guy? Yes. Which is the only side that matters in blue guy that will help me in green guy?
NL.
Yes. This side right here. So I had better work with that side first. If that's the side I am working with, what is my theta that I know? 33. What is this 8.2 compared to theta? It's an hypotenuse of 8.2. What do I need? Adjacent, which is what I do not know. I'm going to call it A would be stupid. I'm going to call it X. What then is it? Cos or sine? Cos of 33 equals X over 8.2. What does X equal? 8.2 cos 33. Should I do that right now? No. Because over here, X is important, isn't it? What is my theta in my second triangle? Which I will do in green. I should have done the first one in blue. What is theta in my second triangle? 49. What else do I know? (8.2 cos 33). What do I need? Opposite, which is y. What uses O and H? So sine 49 equals O y over H. 8.2 cos 53, right? Numbers on the bottom, so what math is it? Multiply 8.2 cos 53 times what? Sine 49. Then you punch that into your calculator. Then you only need to go to your calculator once.
This is how we're doing it now?
Yes.
How did we get to cos 53?
Oh, 33. Sorry. Duh. Thank you. Because that 3 there looks like a 53 to me, even though I wrote it. Cool? The less you go to your calculator, the less chance you have to make errors.
That's just the hypotenuse, but we haven't solved it yet. So we're just shoving
Sure
it
we
into
have.
one factor.
That's what y equals.
Yeah.
That.
That's all I think. I get it now.
Yeah. Do for homework tonight, page 65, 66, and 67. Aight? Tomorrow, after you see all of these correct answers and we discuss them, you're going to do two things. One, you are going to write a quiz. Two, you are going to do some practical measurement. Practical means you're actually going to go and do something. That is tomorrow. Hockly dockly? Hockly dockly. Delicious. Actually, it isn't. I'm going to get a bad pot of coffee this morning. Block B, you are doing pages 65 to 67. Quiz Tuesday. And your practical is Tuesday. Das ist gut. Ha ha ha. Because her name is also Goot. So of course das ist gut. This is good, and this is good.
He's making joke because I'm taking the H away from my last name.
German for good is gut. What's German for God? It's Gott, right? G-O-T, isn't it?
G-O-double-T.
G-O-double-T. Oh. Interesting. Have good days. I will do my bestest.
A couple of announcements. There is a meeting at lunch today in the pit for all teams participating in the Olympics.
Bye-bye.
Reminder to grade 12 students,